Okay, so this is a problem 2.4.18, and they're basically asking us to find the number of elements in A, B, and C. So they want us to find the number of elements in the set A, and the number of elements in the set B, and then the number of elements in the set C. And given this information right here. Okay, so what we want to do is we want to do basically a Venn diagram to try and organize this information. Let's see if I can get all of this on there. And so we have three sets that we're dealing with. We have A, B, and C. So let's label them. Okay, that's B. And the first thing that we want to do, you always want to do on these problems, is start with the intersections. So notice that this piece right here gives us the intersection of all three of them. And if you were to shade that area, it would actually be this area right here. It's where all three of these sets intersect. And they're telling us that it's 6. So we can go ahead and put a 6 right there. Okay? Alright. And then the next thing we want to do is we want to work with both of these intersections and also this intersection, because those are going to be the next piece of information that we can use. So if I take a look at A intersect B, the region of A intersect B is going to be both this region right here and this region right here. So if there's already 6 elements in the intersection, and there's supposed to be a total of 9, then I know that there has to be 3 elements in that part of the intersection. Okay, so far I've used that, and I've used that. I'm going to use B intersect C next, so that's 12 elements, and we're going to use the same logic here. So there's 6 elements here. There's supposed to be a total of 12 between these two regions, so this has to have 6 elements in it. Okay? Alright, so we've used that piece. And then over here, let's do this intersection. A intersect C is 8, so that's these two regions right here. So this must be a 2. Okay. Alright, so the next thing that we need to use is actually this one right here. The number of elements in B minus A is 10. These other ones here, the union and this union, we don't have enough information yet in order to be able to use those. We have too many regions that don't have numbers in them in order to be able to use these two yet. But we can use this. This right here, the number of elements in B minus A is 10. Well, B minus A is actually going to include these two regions right here. This region right here and this region right here. Okay, because when you're looking at B minus A, you're looking at the region that is in B but not in A. So you see right here that these regions, these two regions are in B, but they're also in A. So if I want to do B minus A, then I'm just looking at this region here and this region that has the 6. So again, if these two have to equal 10 total, then this region must be 4. Okay, so now we've used that. Alright, now we can go and we can use this one right here. The number of elements in B union C is 27. Okay, so if I take a look at the union of B and C, it's all of this and it's all of this. So there's only one region right here that I don't have a number for. And if I know that all of this is supposed to add to be 27, then I can take my 27 and subtract each of these numbers, and that should tell me what I have right here. Okay, so if we add these up, this is 10, that's 19, 20, 21, 21 total. We need 27, so this must have 6 elements in it, or a cardinal number of 6. Okay, and then the last piece that we can use here is the union of all of them has to be 30. We just saw that all of these were 27, so there's got to be 30 total, so this region has to be 3. Okay, now they did ask us to find the number of elements in each set, so we just need to add them up. In A, we have 6 and 3 is 9, plus 5, so that's 14. And the number of elements in B is 10 and then 9, so that's 19. And then the number of elements in C, we have 18 plus 2, so that's 20. So those would be your answers there.